Hello, this is the genuinely approachable Sudoku for the 25th of January 2024. It is an average line Sudoku with Bill Murphy. We have lines with some interesting colors here. They're almost as green as the German whisper lines, but not quite. Alright, so let's look at the rules. Normal Sudoku rules apply, so we place the digits 1 to 9 in every row, every column, and every 3x3 box. Digits in circles are the average of the rest of the digits along that line. So, for example, this circle, you take the other two digits on the line and average them and put that in the circle. So basically, this digit here is the average of all those digits. This digit is the average of all those digits, and so on and so forth. And different colored lines are for distinguishing purposes, right? So this digit is an intersection between two lines here. Yeah, so those are the rules. With that, let us begin solving. Now these lines are probably the easiest ones to do because we can already put a digit here. The average of 3 and 1 is just 2, and the average of 7 and 9 is just 8. And if you don't know how to calculate averages, basically what you do is you take all of the numbers up, you add them together, and you divide by how many numbers there are. So there are 4 numbers here, you add them all up and you divide by 4, and you get this digit. And actually a very interesting property about this is that because those digits there are 4 of them, and this is sum divided by 4, this sum here always has to be a multiple of 4, which I'm not sure if we need to know that, but yeah. Alright, so we have some stuff. And we also know that for these lines that have 2 outside and 1 in a circle, what this number has to do is it always has to be between 2 numbers. And the reason why is because if you had 2 numbers lower than this average here, then the average of these 2 numbers is always going to be in between them. Or yeah, what I should say is for any 2 numbers you have, the average is always in between them. And you can sort of prove that, but I probably won't. But what I'm saying is that one of these 2 numbers have to be greater than 6. And they can't be 7 or 8, so they must have a 9 in them. And if they did have a 9 in them, 9 has to add to 3 to make 12, which is 2 times of 6. So this must be with 3 and 9. Now we can do something quite similar here, where there must be a digit lower than 6 here, but can't be 1, 2, or 5. It can't have a 3 as well because of the 3 in the box, so this must contain a 4. And 4 has to add to 8 to make 12 to make... 4 has to add with 8 to make 12, which is 6 times 2. Another thing we can say is that, well, because these are averages, then these 2 digits sum together gives you twice of this digit all times. So I can technically say that those digits sum to twice of 4, which is 8, and same for those digits. So those digits sum to 8 and can't be 3, 5 or 2 6, so it has to be 1 and 7, which we can disambiguate like that. And here we can't have 1, 7, we can't have 3, 5 because of 5 there, so this has to be a 2, 6 pair. Okay. Now those digits have to be 1, 3 and 7. Ooh, very interesting. Actually, no, this is fine, I think. Any subset of this could work. Yeah. But maybe I should think about exactly what those digits could be, right? Because if those were 1 and 3, then this would be 2. If those were 1 and 7, that adds up to 8, so this would be 4. And if it was 3 and 7, it doesn't work because the average would be 5, and 5 is already in the box. So this actually can't be 3 and 7, meaning that can't be 1. Meaning 1 must go there. Okay, I think we could do the same for the rest, I think. Let's just do that real quick. This is 1, 4, and 5. And actually we can't have 4 in here because this has sum to an even number because it's always 2 times of whatever digit this is. So you can't have a 4 in it. 4 would have to sum with an odd number, which always gives you an odd total. So 4 can't be in there. 4 must be in there. These sum to 6. Actually, the 1 disambiguates that. So that's 5, that's 1, and the average of these cells has to be 3, which is 6 divided by 2. Okay, let's do that again. Here we have 3, 7, and 9, which does seem fine. If this is 3, 7, that doesn't work. So because you'd have 5 here, so 9 can't be there. If this is 7, 9, that would be 16, meaning that would be an 8, which is fine. And this is 3, 9, that would be 12, meaning this would be 6, which is also fine. And our last set here, this would be 5, 6, and 9. And same thing here, 6 can't be in here because that will give an odd total, which doesn't work. So 6 must be there. 5 and 9 sum to 14, so the average will be 7. And actually, alright, 7 is one of those cells. I feel like there's something wrong with this being a 7, but I can't tell. So we can't really do anything about that yet. 3 is in one of those cells. Right, because for things with 4 digits on them, you know, you can't say that this has to be between those two cells, because those 2 digits there could change things. It could change it up, I guess. Yeah. Alright, well, 1 though, 1 we can say is here. And we know that 1 is definitely not on the circle, right? Because if 1 was on the circle, you would then imply that those digits sum to 4 times of 1, which is 4, which is just is not possible. And in fact, 1 cannot be in any circle, which is because, you know, we know an average must have 1 higher than it, 1 lower than it, but there's no digit which is lower than 1. And by the same logic, 9 cannot be in the circle because there is no digit higher than 9. Alright, if this is a 3, that would be a 4. And this can't be a 3 then, because if it was a 3, then these would not sum to a multiple of 4, they would sum to 11, which doesn't work. So in fact, 3 has to be there, and that digit therefore has to be a 4, so that the average would be equal to 3. Last digit here would be 6. Wait, am I right here? Those sum to... yeah, that's 9, that's 3. This sums to 12, divide by 4 gives you 3. Yep, that's right. Okay. So we could probably do the same thing here then. Maybe. Not exactly sure because of the 9s. Yeah, we don't know, but we know 9 can't be there. Alright, I'm not gonna delve into the math, because that just feels very... okay, let's see. 5 has to be in the middle cell there. I'm not gonna do the math because, you know, that's just gonna be a lot of work for a general approachable Sudoku. 9 is one of those cells. We already knew that though. 1 in this box has to be there, which we probably also could have done. I think that gives us most of the 1s, right? Yeah, 1 in this box has to be up here. So 1 in this box would have to be here. Okay, that's most of the 1s done. That's all of them done actually. 5 I think I can put in this box. Yep, none of those can be 5. Those can't be 5, so 5 goes there. I think that gives us all the 5s. Yes, that gives us all the 5s. That's all the 5s we have, which is in a very nice windmill pattern. 3 has to be one of those cells. No, I don't think we can do that yet. Okay. Right, yes, 8 in this box. Okay, 8 in this box can't be in those cells, so 8 goes there, which means these must sum to 8 times 2, which is 16, so those have to be 7 and 9. 3 must therefore go there, which is very neat. 3 is in one of those cells, which does help because that makes this a 7, so that's a 3. Those digits average to 5, which means they sum to 10. They can't use 3, 7, 1, 9, or 2, 8, so they must be 4 and 6, which we can disambiguate. Very clean logic there. This 7 pushes a 9 up there. And actually this 1, 3 here means that's just a 2, because that's the average 1 and 3. Okay. I think we can fill in those digits now. Those are 3, 8 and 9, 3, 8, 9. Okay, we can't really disambiguate that, so I'll look at that later. Maybe I should just mark them down. Yeah, this is also 3, 8, or 9. Okay. I really don't want to deal with this line until we get more information about it. Because this one was a lot easier to work with. They're all smaller numbers, which, you know, oh, that can't be a 3. Oh wait, sorry, why did I make this a... oh, this can't be 8 or 3, so it's just 9. What am I doing? That can't be 9. 9 is there. So we now do know that 9 is in one of those cells, which doesn't mean much. If 9 was there, we could probably say something about this being like a 7 or not. Okay, oh, so this 3 sees that cell. So we do in fact know that 9 must now be on here, which does give us something. If this is a 7, this would have to be, well, firstly 7 doesn't, what do these add up to? These add up to 29, right? That's not a multiple of 4, so 7 can't actually be there, 7 must go there. That cell is probably done as 6 to make this average to 7. Yeah, so that these digits would add up to 28, which is 7 times 4. The last digit there is 4. And yeah, okay, so this does make sense. Let's just finish up the Sudoku at this point. This 4 sees that cell, so that's 8. That's 4. Those digits are 2 and 7. That must be 2. That must be 7. That digit would be a 2. That is a 4 and 6, which we can resolve. That is, sorry, a 4. I can't read. 6 here disambiguates this 2-6 pair. Okay, that's weird. This 3-8 pair is still not resolvable. Those digits are 6 and 8, which we can resolve also. Those digits are 3 and 2. Okay, sure. And those would then be 9 and 7, which we can resolve. There you go. And then 9. Yeah, 9 in this box has to be there. This is a 2-3 pair, but this can't be 3, so that's 2. That's 3, that's 2. Well, that digit is really just 8. Those digits are 7 and 6, which you can resolve. I was gonna say 7 and 5. There we have 3 and 4, which we can resolve as well, which does help us resolve this 3-8 pair. Whoa, wrong digit. That would be, well, these two digits are 2 and 8, which we can just resolve automatically, solving the puzzle. That was very nice. Okay, well, I hope you enjoyed that puzzle. We had a decently large amount of math to do in this puzzle. Actually, these average lines do seem pretty cool. So yeah, hope you enjoyed the puzzle. I'll be seeing you next time. Bye bye.